See, today's topic is sympathomimetics and sympatholytics. Okay, before going to discuss about that sympathomimetics and sympatholytics, see here GDC they have launched one new course, that is new batch for Gpat 2025 and 26, that is especially in English language. The admissions are already open. Okay, the live classes that will be starts from the 15th July. Okay, next, see what are the key features of this particular course. See, 500 plus daily live classes will be there, 23 plus hard copy books will be available. Next, 500 plus online test series will be there, 500 plus DPP daily practice paper will be there, 1000 plus pre-recorded videos lectures will be available. Okay, and what is the cost for 2000 GPAT 2025 means 13,600 it is. For GPAT 2026 it is 17,800. Okay, this is about the course information. Next, another course is there, that is GDC Prime Plus. Okay, this is also especially designed for the English language. Okay, for the South region. See what are the key features of this particular course is 500 plus live recorded classes, 500 plus video lectures, 35 plus previous year question papers. Okay, 500 plus DPP, 500 plus online test series with explanation and ebooks. All these are available for the GDC Prime Plus course. Okay. See, when it comes to the sympathomimetics and sympatholytics, see, first one is sympathomimetic drugs that can be classified into directly acting drugs, indirectly acting drugs, and mixed acting drugs. Okay, under the directly acting drugs catechols basic nucleus containing drug, that is endogenous. E nothing but epinephrine, N nothing but norepinephrine, D nothing but dopamine. Okay. Next, when it comes to the exogenous means already present in our body, that is isoprenaline. Okay, sorry, endogenous nothing but already located in our body, exogenous nothing but that can be taken from the outside. Example is isoprenaline, dobutamine, dipivifrin, okay, dopixamine, phenaldopam. So this is all these drugs contains catechol as a basic nucleus. Next, directly acting, that is non-catechol ring containing drugs, that is alpha 1 selective agonist. Okay, example is phenylephrine, nefazolin, oxymetazoline, 𝘿𝙄𝙎𝘾𝙄𝑖𝑙. These drugs alpha 1 selective agonist can be used as a nasal decongestants. Next, alpha 2 selective agonist, that is clonidine, apraclonidine, methyl dopa, and guanafacin, guanabinge. See, these drugs can be used in hypertension condition. Okay, next, beta 1 selective agonist, that is catechol ring containing drug, that is dobutamine. So it is used in congestive heart failure because beta 1 receptor majorly present on heart. When it comes to the alpha 2 receptor, it is located on the in the brain. Okay, next, alpha 1 receptor, that is majorly located on the blood vessel. See, beta 2 selective agonist, that is yes, salbutamol, terbutaline, salmeterol, formoterol, okay, and metaproteinerol. These drugs can be used in asthma because beta 2 receptor, that is majorly present in bronchi. See, beta 3 receptor it is clinically not useful. Next, when it comes to the directly acting drugs, tyramine, amphetamine, methamphetamine, methylphenidate. Next, when it comes to the mixed acting drugs, ephedrine, pseudoephedrines, two drugs are available. See, when it comes to the functional groups priority, okay, this thing is very much important. This functional group priority is very much important. First one is cations. Cations will get the more priority. Okay, here cations nothing but ammonium containing, okay, phosphonium, okay, like that. Ammonium, phosphonium, sulfonium containing drugs will get first priority. Functional group will get first priority. Next, carboxylic acid. Next, sulfuric acid. Next, N-hydride. Next, ester, acid chloride, amide. After that, triple bond containing drug. that is cyanide, isocyanide. Next, double bond containing, that is aldehyde and ketone. Next, when it comes to the alcohol group, okay, mercapto group and amine group, alcohol group will get first priority, then SH, then amine group. Next, ether group is there, followed by alkene will be there, then alkyne will be there. So this is the just brief information about the functional group priority. See, first one is rules to write the IUPAC name of a drug. First, we need to identify, three rules are very important. First, we need to identify the functional group in that particular given drug. So this is the first given drug. We people need to identify the functional groups. Alcohol is there, another alcohol is there. Next, here amine group is there. Okay, just now we have discussed what are the functional groups. Here amine group is there, like alcohol and amine group is there. Next, give the numbering. See, we need to give more priority, means two alcohol group is there, here only one, so two alcohol group will get more priority, OH group will get more priority than amine group. Hence we need to start the numbering from this OH group containing. See, like this numbering should be given like this. Then after that, again this is a small branch, again 1 and 2 numbering should be given. Next, write the IUPAC name. Identify the functional group, give the numbering based on priority of functional group, then write the IUPAC name. See, when it comes to the writing of IUPAC name, we people need to write from the back side to the front side. First, we people have identified a functional group, that is on benzene. Okay, hence benzene 1,2 diol. Okay, na? After that, what is there? Benzene that can be attached to the ethyl group. Okay, again ethyl group, it contains two substitutions. What are those substitutions? One is methylamine, another one is hydroxy. See, this name is hydroxy, this name is methylamine. Then see, H letter will come first as per the alphabet, then M letter will come. Hence, at fourth position, what we are mentioning here, 1-hydroxy, 2 position, what is there? Methyl amino group is there. So like that, we need to write the IUPAC name for all the drugs. So this is already we have discussed. Next, epinephrine. So just now we have discussed. See, AP, okay, AP nothing but see, AP nothing but upon, E nothing but ethyl group is there, pH nothing but phenyl group is there, R nothing but hydroxy, okay, I nothing but amine moiety is there, that is tertiary amine. So this is the epinephrine. Just we people have discussed now the IUPAC name of this particular one. Okay, when comes to the, see, these drugs mnemonic ABCD. A nothing but anaphylactic shock, IV route, by IV route we can use bronchial asthma, okay, cardiac arrest, prolonged duration of local anesthetic, and it can control epistaxis. So in all these conditions we can use this particular drug. Epistaxis is nothing but nose bleeding. Next, norepinephrine. See, epinephrine nothing but on amine group, it contains methyl, but norepinephrine nothing but it do not contains methyl group. Hence we can call it no radical. Okay, AP. See, same ethyl group is there, phenyl group, hydroxy group, and amine group. When comes to the IUPAC name, we need to identify the functional group. Amine, alcohol group. Here two alcohol groups are there, so it will get the first priority. So numbering should be given like this. Then branch we need to give like this, the numbering. Then we can write benzene 1,2 diol, that is common, it can be attached to the ethyl group. Then it contains, what it contains? Amine group and hydroxy. Amine group. So which functional group we need to write first means amine, because which substituent means amino, because A letter will come first, then H letter will come. Hence we need to write amino hydroxy group. Next, dopamine. When comes to the dopamine, okay, see, this is the structure of dopamine. See, dopamine, it contains dihydroxy, 2-hydroxy group is there, phenyl group is there, next amine group is there. Hence the name is dopamine, dihydroxy phenylamine. Okay, next, when comes to the IUPAC name of this particular drug, amine group is there and alcohol group is there. Okay, alcohol group will get the more priority than amine group. Hence, start the numbering from the alcohol group containing carbon like this. So what is there? Benzene 1,2 diol. Next, what is there? Ethyl that can be attached to the ethyl, that is second 2 amino. It contains only one substituent, that is 2 amino ethyl. It can be attached at fourth position. Next, isoprenaline drug is there. So this is the isoprenaline drug. Isoprenaline that contains isopropyl group. Next, ethyl group. Next, nol, phenyl, INE, amine. See, like that, the from the name only we need to write the structure of the drug. Next, next, what we people need IUPAC name. When it comes to the IUPAC name, first we need to focus on functional group. Same will be there. Okay, alcohol and amine. So alcohol group will get the first priority. So numbering should be given like this. So here what is there? Benzene 1,2 diol that can be attached to the ethyl group. Ethyl group, it contains hydroxy group. Here it contains isopropyl. We can call it a isopropyl group. Okay, here it is hydroxy. So H letter will come first as per the alphabet, then I letter will come. Hence what we are writing, 1 hydroxy means first carbon it contains hydroxy, second carbon it contains isopropyl amino group. Okay, at fourth position. So this fourth indicate this one. Next, 𝙁𝙬𝑡amine. Okay, see 𝙁𝙬𝑡amine, the dopamine, from the name it is dopamine. See what is the dopamine? Dihydroxy phenyl amine. So that is a dopamine. But nothing but extra, it contains butyl group here. Extra, it contains butyl group. Okay, then that's why we can call it 𝙁𝙬𝑡amine. When it comes to the IUPAC name of this particular drug, first we need to identify same amine group, alcohol, here 2 alcohol. So we need to give diol as a first priority like this. Then we can go for the branch 1 and 2. Again another branch is there, that is butyl group. Okay, again phenyl group we need to give, because phenyl group that contains OH group as a substitution. Hence what we need to write, benzene 1,2 diol that can be attached to the ethyl group. Okay, ethyl group attaches to the amino group. Okay, next what is there? Amino group that can be attached to the butyl group. Okay na. Next, what is their butyl group at fourth position? Fourth position of butyl group, it contains 4-hydroxyphenyl butane. This 4 indicates this one. Okay, so that is a 𝙁𝙬𝑡amine structure. When comes to the nephazoline, so this is the structure of nephazoline. See, naphthalene is there. So this is a naphthalene. Azolene, this is a azolene structure. Okay na. Next, what is there? See here, naphthalene is there, aromatic ring, here heterocyclic ring is there. So aromatic ring is more stable but heterocyclic is more reactive, hence we need to give the numbering to the or preference to the heterocyclic group like this. Then we can go for a naphthalene like this. Then what we need to write? See 4,5, fourth position, fifth position, it contains hydrogen, hence 4,5 dihydro 1H-imidazole. One position it is containing hydrogen, hence 1H-imidazole that can be attached to the methyl group. Okay. Next, it contains naphthalene 1-yle. First position it is attached to the methyl, hence naphthalene 1-yle it is. So that is the nephazoline, can be used as a nasal decongestant. Next, oxymetazoline. So this is a structure of oxymetazoline. Oxy nothing but it contains hydroxy. Okay, it contains methyl group along with azolene. Aza nothing but nitrogen. Ol nothing but 5-membered. I nothing but 1 double bond less, means only 1 bond will be there. Normally 2 bond is there, one can be replaced, hence azolene. So when it comes to the IUPAC name of this particular drug, what is there? functional group, only hydroxy group is there, so we need to give more priority to the hydroxy group containing phenyl group like this 3 4 5. Then we need to give numbering to the heterocyclic ring. So phenol is the basic moiety. Okay, OH group present on benzene, that is phenol. Okay, at 6th position it contains one substitution, 4th position, second position and third position. See, all are substitutions only. So which one we need to write first means based on alphabet. What is the name of this one? Methyl. So this name is methyl. So what is the name of this one? Tertiary butyl. Okay, tertiary butyl. Next, what is the name of this one? 4,5 dihydro, 4,5 dihydroimidazole. So D letter will come first, then which one will come? Then here, see, here also di will be there, here di will be there, but H letter will come first, then F letter will come second. Hence 2,4 dimethyl. Last one is tertiary butyl. Okay, 6 tertiary butyl phenol. Okay, 6 tertiary butyl phenol it is. Okay, so this is the oxymetazoline IUPAC name. Next, 𝘖𝙬𝙎𝙐. So this is the structure of 𝘖𝙬𝙎𝙐. So it contains xylidine moiety, okay, methyl group and azulene. So here no functional group is there, so we can consider as a 4,5 dihydroimidazole as a basic ring because it is a heterocyclic, more reactive. Then benzene we need to give the numbering like this. So 4,5 dihydroimidazole, okay, that can be attaches to the methyl group. Okay, methyl group that can be attaches to the phenyl group. That phenyl group it contains 3 substitutions, that is 2,6, okay, 2,6 dimethyl. Okay, next at 4th position what is there? Tertiary butyl. At 4th position it contains tertiary butyl. Hence B letter will come first, D letter will come second. Hence what we are writing here? Sorry, see, that's why we are writing 4 tertiary butyl, 2,6 dimethyl, then phenyl. All of this present at second position, so this one is here. Next, clonidine. See, clonidine, this is the structure of clonidine. It contains 2 chlorine groups. Okay, next one is aniline moiety. So this is aniline moiety. Next, dine nothing but imidazolidine. Okay, so when it comes to the IUPAC name, amine group is there. So heterocyclic compound we need to give first numbering, then aromatic ring, that is benzene. So here what is there? 4,5 dihydroimidazole, dihydro 1H imidazole, 2-amine. 2-amine is the functional group here. Then what is there? 2,6 dichlorophenyl, that is located on nitrogen. Okay, next methyl dopa. Methyl dopa, it is a prodrug. Methyl dopa, it is a prodrug. See, dopa nothing but dihydroxyphenyl, okay, alanine. Okay, dihydroxyphenyl alanine. So dihydroxyphenyl is up to here. Okay, alanine moiety is here. It extra, it contains methyl group, hence we are mentioning here methyl dopa. Okay, hence we are mentioning here methyl dopa. Next, when comes to the IUPAC name of the drug, for that we need to identify functional group. Amine group is there. Next, carboxylic acid is there. Carboxylic acid. Next, alcohol group is there. See, among these 3, carboxylic acid will get the more priority. Hence, when comes to the IUPAC name, so numbering first we need to give 3 carbon. Okay, na? Then benzene also we need to give numbering because 2 substitutions OH group is there. See, propanoic acid, 3 carbon containing propanoic acid. Okay, second position it contains methyl group, second position amine group, third position it contains this substitution. So amine group, okay, we need to write first because A letter will come as per the alphabet. Next, 3,4 dihydroxyphenyl. Okay, H letter will come, then 2-methyl, that is at last, then propanoic acid it is. Next, salbutamol. When it comes to the salbutamol, it is a salicylic acid derivative. Okay, here CO double carbon double bond with oxygen will be there. Upon reduction it will gives CH2 group. Okay, that's why salicylic acid is there. Next tertiary butyl is there, amine group is there, alcohol group is there, hence the name is salbutamol. When comes to the IUPAC name, amino, alcohol, alcohol. So alcohol present on benzene we need to give the more priority, hence phenol it is. So this is a basic ring. Okay, so numbering we need to give like this, again substitution like this. Then second position this substitution is there, fourth position this entire substitution is there. Second position what is that? Hydroxy ethyl. Second position what it contains? Hydroxy ethyl. Next fourth position what it contains? Tertiary butyl amino. Okay, tertiary butyl amino, 1 hydroxy. Okay, that is 1 hydroxy ethyl, 1 hydroxy ethyl, hydroxy methyl. So this is a hydroxy methyl here. Phenol, hydroxy methyl phenol it is. See why we are writing this one means B letter will come first, then H letter will come. Okay, then H letter followed by M letter. So here H letter followed by E letter, so we need to write first this one, then hydroxy methyl group this one, last then phenol it is. Next terbutylene. When it comes to the terbutylene structure, see tertiary butyl is there. Okay, then amine is there, hence the name it is terbutylene. Alcohol group is there, so we need to give more priority to the alcohol group. Then this one, what is that? Benzene 1,3 diol. Okay, same, what is there? One position it is containing hydroxy, second position it contains tertiary butyl amino, that is located at 5th position. Okay, so this is a terbutylene structure and IUPAC name. Next amphetamine. So this is the structure of amphetamine. So first AM nothing but amine group is there, phenyl group is there, ethyl group is there. Okay, again AM amine nothing but amine group only. When comes to the IUPAC name, it contains only amine group as a functional group. So we need to give these carbon atoms as a numbering. So we need to start like this, numbering 1 2 3. Okay na? Hence 2 amine, first we need to write 2 amine, that is functional group. Okay, 2 amine, propane it is propane, then substitution is phenyl, 1 phenyl. Okay, next hydroxy amphetamine. See the same amphetamine only, if we have added hydroxy, then hydroxy amphetamine it is. See then if alcohol group will get alcohol group will come, hence phenol will get more priority here. Phenol group that can will get more priority, that is phenol. Then what is there? Numbering is like this, 1 and 2 3. Okay, next 2 amino propyl, 2 amino propyl, that is at 4th position. Then phenol is a basic nucleus here. Next ephedrine. So this is the structure of ephedrine. See here ephedrine, E nothing but ethyl group is there. Okay, next phenyl group is there, next hydroxy group is there here, next iron nothing but amine group is there, hence it is ephedrine moiety will be there. Next when comes to the IUPAC name, the drug it contains hydroxy group, amine group, so we need to give more priority to the hydroxy group, hence numbering is OH group containing carbon 1 and 2 and 3. Then this is a substitution, this is also substitution. Propane 1 all. See propane, that is 1 all. At one position it attaches to the phenyl group, second position it is contains methyl amino, second position it contains methyl sorry second position it contains methyl amino group. Okay, that is the ephedrine moiety. See here R and S enantiomer it is. Okay, R and S enantiomer, that is ephedrine. Pseudoephedrine also same, but here OH group is above the plane. Okay, OH group is above the plane here. See here same, the IUPAC name is same. Propane 1 all 1 phenyl. Okay, second position it contains methyl amino group. See this is a SS enantiomer, but previous one is sorry. See, previous one is RR enantiomer it is. Next, when it comes to the structural activity relationship of this sympathomimetic drugs, see this OH group is there. See this OH group in dopamine, it may leads to the central nervous system activity. It should be R configuration. The here the configuration should be R configuration. Okay, this OH group increases the binding to the alpha and beta receptors. Example of this OH group containing drug is epinephrine and norepinephrine. Next, it involved in hydrogen bonding to the receptor binding site. Means it will form hydrogen bond with receptor. Next, amine group is there. Amine group upon ionization, it will get positive charge, hence it will forms ionic bond with receptor. Next, R1 group. See, R1 group larger substitution that increases the selectivity for beta receptor. Example is isoprenaline. Say isoprenaline that contains isopropyl group, so it is a larger substitution, hence selectivity towards the beta receptor. See, if R1 is larger than tertiary butyl, like aryl alpha methyl alkyl groups, then affinity for the beta receptor, but there is no intrinsic activity. It means more lipophilic groups can offer the blocking activity, hence the drug, it can be acts as a beat blocker drug, that is 𝘖𝙁𝙁. Example of the drug is 𝘖𝙁𝙁. Here R epinephrine is has 12 to 15 times more vasopressor activity compared to S epinephrine. Next, R2 position. If R2 position that contains methyl group, okay, methyl group, then it will increases the CNS activity because of increasing of non-polar nature. Example of the drug is ephedrine. OH group. So if the OH group, if we have removed this OH group, then if you have transferred to this carbon atom, then we can call it a terbutaline. The name of the drug is terbutaline. If two OH groups are side by side on benzene, then we can call it a catechol drug. See, catechals can immediately metabolized by the monoamine oxidase enzymes. Hence, if you are removing this OH group shifted to this carbon, then what will happen? It is resistant to the metabolism, hence decrease the metabolism of the particular drug, then longer duration of action, the drug is orally active. Next, aromatic ring. See, this aromatic ring that can be involved in van der Waals interaction with receptor. Next, OH group is there. This 2 OH group that is responsible for binding to the alpha and beta receptor. If we people have removed this OH2 group, OH group, instead of OH, if we people have make it CH2 OH group, that is in case of salbutamol, okay, then what will happen if 2 OH group is not there, then automatically decreases metabolism, longer duration of action, the drug is orally active. Next, the example of the drug is salbutamol it is. Next, structural activity relationship of sympathomimetics. Here amine group. See, this amine group that can be involved in ionic bonding to the receptor, okay, primary and secondary amines. Primary and secondary amines are more potent as compared to the tertiary and quaternary amines. Okay. Next, R1 group. See, if this R1 group as the bulkiness increases, it increases the beta 2 selectivity. Okay. Nothing but if the moiety is bulkier moiety, not methyl and ethyl, it is bulky moiety will be there, then increases the selectivity towards the beta 2 receptor. Example is tertiary butyl group that can increases the beta 2 selectivity in terbutaline and salbutamol. So this is the structure of terbutaline, this is the structure of salbutamol. Next, larger substitution on amino group decreases the metabolism. So this larger substitution that can make steric hindrance to the enzyme, so that it will prevent the metabolism of this catechol ring. So like that, 2 advantages will be there. Okay. Next comes to the metabolism of the catechol nucleus. See, norepinephrine is there in the presence of monoamine oxidase that can be converted into aldehyde. Okay, this CH2 that can be converted into aldehyde. Again, aldehyde upon oxidation that can be converted into carboxylic acid. Okay, next that can be converted into alcohol group. Okay, with the help of catechol orthomethyl transferase, see this orthomethyl, this hydrogen can be replaced with methyl group. Same here also, this hydrogen can be replaced with methyl group with the help of COMT enzyme. Then what will forms 3-methoxy 4-hydroxy phenyl glycol. Okay, 3-methoxy 4-hydroxy mandelic acid. Okay, okay, simply we can call it a vanillyl mandelic acid, VMA. Okay, MHPG here. See, with the help of COMT, norepinephrine that can be converted into normetanephrine. Okay, in the present, with the help of monoamine oxidase, finally it will form this particular product. Okay, finally that will forms here. What will be there? Aldehyde will be there upon. Okay, again this can be converted into this particular metabolites, MHPG and VMA. So this is about the sympathomimetics drugs classification, IUPAC name, structural activity relationship along with metabolism. Okay.